Section 2.2, Frequency Distributions. So we've learned about the different types of experiment or observational studies we can do. So wherever our data comes from, now we need to understand how to work with that data that we've collected. So one way to organize just raw data, just a bunch of numbers, is in a frequency distribution. A frequency distribution is raw data organized in table form using classes and frequencies. Frequency distributions help us to understand the general trend of the data. So just looking at a bunch of numbers, usually it's very hard to see what's going on, but once we organize it into a table or a frequency distribution, we can tell if there's any trends, and then from there, from a frequency distribution, we can organize further into charts or graphs. So let's take a look at example 1. We have a random sample of 25 households in a particular viewing area, and it produced the following estimates of television viewing hours per day per household. So, of course, in a more detailed study, we might want to know how many people live in the household, are there children under the age of 18, things like that. But just for the purposes of this example, all we know is the number of viewing hours per day. So given the classes below, determine the frequency for each class. So in this particular chart, they told us what the classes were. And here are the classes here, 1 to 3, 4 to 6, 7 to 9, 10 to 12, and 13 to 15. So our job is to look at the raw data and tally how many data values fall within each class. So let's go through the first class, 1 to 3. So it looks like I have that first 3, and then the 1 in the third row, and the 3 in the third row, and then the 2 and the 1 in the last row. So that gives me a total of 5 data values that fall in that class. And we'll do the other classes in a similar fashion. So going through all of our data, I come up with this tally. So as we mentioned before, we had 5 in the class 1 to 3. Looks like we have 9 in the class 4 to 6, 7 in the class 7 to 9, 3 in 10 to 12, and just 1 data value that falls in class 13 to 15. One little thing you can do to make sure you captured all the data values is to add up your frequencies and make sure they sum to the original number of data values. So we were told we had 25 households, which means we have 25 pieces of data. So 5 plus 9 plus 7 plus 3 plus 1 should add up to 25, and it does. So it's not a guarantee that you got everything in the right place, but it at least lets you know that you didn't forget something or maybe count something twice. So now that we've organized our data just from a bunch of numbers to a frequency table, we can already see a trend. We can tell that most households watch between 4 and 6 hours of television daily, just looking at how 9 data values fall in that class. Well, there are a couple of different components of a frequency table, so let's just make sure we understand them all. And we'll use this information a lot more when we take a frequency table and we put that information onto a graph. So the first thing, we've kind of talked about this already, are class limits. And these are the high and low numbers of each class. So if we go back to that first class, 1 to 3, 1 is our lower class limit, and 3 is the upper class limit. Again, if you were to look, let's say, at the last class, 13 is the lower class limit, and the upper class limit would be 15. Then you have what are called class boundaries. Now notice what's going on with the class limits, and especially this type of data, it looks like it was collected in a discrete form. Now we could, with time, it could be noted as continuous. We could get things down to the half hour or quarter hour or to the minute or the second, but it looks like the way this data was collected, it was just every full hour. So if you look at our classes, we go from 1 to 3, 4 to 6, 7 to 9, etc. And there's those spaces in between that are not accounted for. And that's what we want to accomplish with the class boundaries. So these are the numbers that separate the classes, but without any gaps. So currently we go from 1 to 3, and then 4 to 6, but there's some numbers in between 3 and 4, and we want to take that into account. So the class boundary helps to eliminate that graph, and that gaps rather. And that's going to be really important when we start to graph. The class boundary between 3 and 4 would be 3.5, so it's pretty much halfway in between. The next gap between 6 and 7, the class boundary would be 6.5. So you can take the upper class limit from one class and the lower class limit from the next class and just find the middle, the average, and you'll be able to find the class boundary. Okay, so we've talked about class limits, class boundaries, then we have the class width. And this is the span or width within a class, and it also happens to be the width between two classes. When counting the width within a class, be sure to include the lower and upper limits. So don't just subtract to get the class width. So for the second class, 4 to 6, if you were just to say, oh, well, 6 minus 4 is 2, that's not actually correct for the class width. With the class width, you want to count both the lower class limit and the upper class limit and everything in between. So for the second class, 4 to 6, we would count 4, 5, and 6, and it actually has a class limit of 3, not 2. If you'll notice, that same distance is also between the first and second classes. So if you look at the lower class limits from 1 to 4, well, that's a difference of 3. From 4 to 7 is a difference of 3, 7 to 10, and so on, and it happens on the other side as well, 3 to 6, 6 to 9. So all of that's there in place because it's really important with the frequency table that the class widths are the same. You can't have one class width be 3 and then the next one be 6. That's not an accurate and reliable frequency table. So that's why it's important that we pay attention to the class width. Lastly, we have the class midpoint, and this is the center value within a class. So class boundary is kind of between the classes. Class midpoint is within a class. And to find the midpoint, you just add the lower and upper class limits and divide by 2. So for the first class, 1 to 3, I take the 1 plus 3, divide by 2, which is 4. 4 divided by 2 is just 2. Again, this is another component that will be really important when we start to graph. Okay, let's take a look at example 2. The pulse rate, or beats per minute, of 40 males is given below. Use this data to construct a frequency distribution with 7 classes. Well, what do you notice here? If you notice, unlike with our last example, we don't have any classes. We have to figure them out ourselves. But they gave us a little bit of information. They told us that we should end up with 7 classes. Well, we have to decide what those classes are going to be. One thing you want to do is look at the lowest data value and the highest data value and kind of go from there. So looking at our data here, we have 68, 64, and it looks like one of our lowest data values is a 56th. And then one of the highest would be, let's see, is there something bigger than 88? Looks like we have 96 as a high. And this part's kind of a little bit of a style or personal preference thing. We could go, not 99, but 96. We could go exactly with 99 and 90, or 56 and 96 rather. But usually it's a good idea to be a little bit wider than what your actual data is. So I'm going to go from 50, so a little bit before 56, and up to 99, a little bit after 56. And what we're going to do is take the difference. Figure out what the difference is between those two. So 99 minus 50 is 49. And remember, we were told we want 7 classes. So if I divide 49 by 7, that tells me that the width of each class will be 7. Okay, so let's take a look at our first class. Our first class, since we kind of backed off of 56, was 50, was our lower class limit. What's going to be the upper class limit? I have to have a width of 7. I've already determined that, and that's going to make me fit my 7 classes between 50 and 99. Well, remember, with the class width, I'm counting the lower class limit and the upper class limit. So my upper class width is not 57, but 56. So remember, if you were to count 50, 51, 52, 53, 54, 55, 56, that's 7, a width of 7. Let's go ahead and finish out our classes. So if the first class ended on 56, then the next one will have to end on, or start rather, on 57, and it's going to go up to 63. And then the next class will start at 64 and go up to 70. And notice, just as we mentioned before, in between the classes, we still have a difference of 7, from 50 to 57, from 57 to 64. Let's go ahead and fill in the rest of these. And now with our last class, 93, we'll land right on that 99. Now, this is not the only way to do this one. I just chose to not be exactly at 56 and not be exactly at 96, just to make my classes a little bit easier. You certainly could have chose some different values, but you still would have needed to divide by 7 to figure out the width of each class. One thing I was trying to do here is kind of keep things with whole numbers, so we wouldn't have decimals and fractions, at least not at first. Okay, so we have our class widths. Now we need our class boundaries. Remember, class boundary is going to separate our classes but put them closer together. So first, let's take a look between 56 and 57. Right now, they're 1 unit apart. There's nothing in between 56 and 57. They're not touching. So you pretty much want to ask yourself, well, what's halfway in between 56 and 57? And that upper class limit would be 56.5. If you go on the other side of 50, that would be 49.5. So that first class boundary, 49.5 to 56.5. Notice that the width is still 7. That should be maintained. Now for our second class, I'm going to start at 56.5 this time. There won't be the gap the way there was with the class width, but this is going to go up to 63.5. And then the next class will start at 63.5 and go up to 70.5. And again, we still have that width of 7 even in between the class boundaries. And let's go ahead and finish these up. Okay, so now we have our class boundaries in place. Next, my job is to tally. Now for me, it's a lot easier to look back at the original class width than to look at the class boundaries and look at those 0.5s. Either way, it would turn out the same, but usually just for ease of looking at the numbers, you can look back at the class width. So again, I'm going to go through my raw data and tally up how many data values fall within each class. So between 50 and 56, I'm getting that I have 6 values. And then for 57 to 63, I end up with 7. And then let's fill in the rest of this. Okay, so that's our tally, and so just for regular numbers, I have 6, 7, 10, 8, 4, 4, and 1. And again, a way to make sure you got all data values is to tally up your frequencies, and this should sum to 40, which it does. Okay, so that wraps up 2.2. Make sure you get some good practice with studying up the class width and the class boundaries, because you will use this skill when we get to graphing histograms.